Hi students, last class we seen that the solid state question paper, previous year question paper. In this video, we are going to learn about the solutions. The second chapter, solution, up to 2015 or 2016. That question paper up to 2015 to 2016. Then in this chapter, mainly you have to concentrate. I will tell you which topic you have to concentrate. First, the solubility. Before that, the expressing the concentrations of the solution. Then the solubility based on the Henry's law and the Raoult's law. After that, the ideal and the non-ideal solution. So usually in this part, theoretical questions are comes. After that, the colligative properties, ideal and non-ideal solution, then colligative properties. The colligative properties mainly relative lowering the vapor pressure, elevation of boiling point, depression of freezing point and osmotic pressure. So these topics usually comes the numericals. Repeated numericals mean freezing point and the boiling point, sometimes asking the vapor pressure based questions and the osmotic pressure based question. All these numerical types of numericals also I am going to discuss here. Hi students, see today we are going to discuss about the second chapter, that is solution, CBSE previous year question papers, that is question and answer. In this chapter mainly you have to concentrate the solubility. The different types of that is solubilities are given there. So the solubility based questions, then the Henry's law and its application. This is a very important one. Many of the times the applications are sometimes are coming, that is in all India questions or regional wise question and foreign wise question. Usually the application, Henry's law applications, then Raoult's law will come. That is the statements of the Raoult's law. Then the ideal and the non-ideal solution. This is the very important thing. There are two types of that deviations are there for non-ideal solution. If there is ideal solution means that obeys Raoult's law. Non-ideal solution means does not obeys Raoult's law. So here the non-ideal solution have positive and the negative deviation. There is the different types of the positive and the negative deviations are there. There is a different examples are there. You have to concentrate this part. And after that, the colligative properties. The colligative properties mainly the relative lowering the vapor pressure, boiling point, elevation of boiling point, depression of freezing point and osmotic pressure. Based on this, numericals will come. This is very important. The numerical part mostly comes from this numerical part only for finding the delta TB or delta TF or pi, that pi indicates osmotic pressure. So the numericals comes from this part and the theory, like theoretical questions come this part. And the abnormal molar mass. The academic year 2021, we don't have that abnormal molar mass. This is the deleted part, so just omit this. The remaining things you have to read. So more concentrate these type of questions. First we will see the numerical, the different types of the numerical, then formulas are used. These things we see, then after that we will discuss some questions. See, in this chapter mainly you have to concentrate, commit to memory these formula, these four types of formula. That is based on the colligative properties. First, here the delta TB is equal to KB into M. Here the delta TB is equal to TB minus TB naught TB naught B. Here the delta TB, that is the boiling point, is equal to KB into mass. This entire term is WB into 1000 divided by WA into M2. Here already you know that, or you can use it instead of W2, that is WB instead of W2. You can use it. Some of the books use W2 or some of the books are using WB, both are correct. Or you can write it WA, W1, M2, or you can write it here, that is MB, here M2. And similarly, that same for delta TF also. You can use it M. This mass indicates WB into 1000 divided by WA into MB. Here the KB is molal elevation, that is boiling point constant. Molal boiling point constant or ebullioscopic constant. Usually the KB values are given. Then delta TF. This is for boiling point and this only the change is KF. Here because of the freezing point. This is a boiling point and this is a freezing point. So WB 1000 divided by WA into MB, or you can write it W 2000 divided by W1 M2. You can use it either this or this. Any one you have to use. So this is for boiling point. The second one is for freezing point. Then usually the formulas are used for the osmotic pressure. This is for boiling point, this is for freezing point, and this is for osmotic pressure. The osmotic, pi is the osmotic pressure, C is the molar concentration, R is the gas constant, T is the temperature. You know that C, that is number of moles divided by volume. Concentration indicate usually number of moles divided by volume. So that we can write it pi is equal to N by V RT, or sometime you can use it pi V is equal to N RT. That is also one of the term. So you can use it, this formula for osmotic pressure, finding of the osmotic pressure value. Then based on the Raoult's law. Based on the Raoult's law, usually you know that is P naught minus Ps divided by Ps is equal to N2 divided by N1. That means the number of moles of solute and number of moles of the solvent. So this is for both diluted and the concentration solution. According to the Raoult's law, you can use it, this formula for both diluted or the concentration solution. So these are the formula we are using the colligative property based numericals. So look at this numerical based on the freezing point. See, a 10% solution of sucrose in water has freezing point of 269.15 Kelvin. Calculate the freezing point of 10% glucose in water if freezing point of pure water is 273.15 Kelvin. So molar mass of the sucrose is given here 342 gram per mole and glucose is 180 gram per mole. So we want to calculate the freezing point of 10% glucose in water, where if the freezing point of pure water is 273.15 Kelvin. So first the sucrose, freezing point of the sucrose. So delta TF is equal to TF naught minus TF. That means pure solution, that is pure component. So here that is 269.15. So sucrose, here the pure is what? 273. So that 273.15 Kelvin minus TF is what? 269. So 269.15 Kelvin. So delta TF for sucrose will get 4 Kelvin. So what is here? Delta TF is 4 Kelvin. Then now delta TF is 4. Then the remaining part you have to look. The formula is, you know that delta TF is equal to KF then WB into 1000 divided by divided by WA into MB. So this is the formula. Now you have to find out that delta TF is given here, then KF WB. What is the WB? WB is a weight of solute. So here the weight of solute is what? Solute, this is sucrose. So weight of solute is divided by the molar mass of the solute. Then the weight of the solvent. So weight of solute is what here? 10% solution of sucrose. So that weight of solute is 10%. This delta TF is 4, then KF, WB is what? 10%, then divided by weight of solvent. So solvent is remaining as 90%, so that 90 into molecular mass of solute. So molecular mass of the solute sucrose is 342. So simplify this, then this will be equation 1. Then this is for sucrose. Now delta TF for glucose. This is glucose and this is sucrose. So the similar way you have to follow, then the delta TF into KF, the WB, same formula you have to write, WB into 1000 divided by MB into WA. So what is that WB here? Weight of solute. So weight of solute is here also what is 10% glucose. So that weight of solute 10. So KF is equal to 10 into 1000 divided by MB. Here molecular mass of glucose. This is for sucrose, that is why 342. This is for glucose, so 180. 180 into weight of solvent. Weight of solvent here also the same thing, 90%. Now this equation will become 2. This is delta TF is equal to KF. This is for glucose and this is for sucrose. See, look at this. Dividing the equation 1 by equation 2. So equation 1 is what? 4 to KF 10 into 1000 divided by 342 into 90. So this is the equation 1. So divided by 2, the delta TF is equal to KF to 10 into 1000 divided by 180 into 90. So here I am going to cancel the terms KF, then 10 into 1000, 10 into 1000 here also, then 90, everything is cancelled. Then the remaining thing is what? 342 into 1 divided by, that is 180. So on rearranging this equation, that is delta TF, this means 4 delta TF is equal 342 divided by 180. On rearranging this equation, that is delta TF is equal to 342 into 4 divided by 180. So on simplifying this, you will get some value. Just simplify this, 342 into 4 divided by 180, or taking log. I hope you will get the value is 7.6. So 6 Kelvin. That means 6 Kelvin. So delta TF. So now here the question is what? Calculate the freezing point of 10% glucose in water if the freezing point of pure water is 273.15 Kelvin. So remaining you have to do the same calculation, that is 273 delta TF is equal T0 F minus TF. Here what is the 7.6 Kelvin here. So then already we have 273.15 Kelvin. So 273.15 Kelvin minus 7.6. So finally we will get 265. So 265.11 Kelvin. sorry 155 Kelvin, 265.55 Kelvin. This is the freezing point of the glucose, 10% glucose. This is the answer. Next sum, calculate the mass of compound to be dissolved in 75 gram of benzene to lower its freezing point by 0.48 Kelvin. So Kf given, the Kf value is 5.12 Kelvin kilogram per mole. See here you have to calculate the mass. Mass means weight of that solute. So mass of compound to be dissolved. So that you want to calculate the weight of solute, Wb you have to calculate. Then the given values. First write the formula, the delta Tf is equal to Kf into Wb 1000 into 1000 divided by Mb into Wa. So this is the formula. Now here the delta Tf, freezing point. So lower its freezing point by 0.48 Kelvin. So that here delta Tf is what? 0.48 Kelvin. Then Wb we want to find out the Kf. Kf value is also already given there. That is Kf is equal to what? 5.12 Kelvin kilogram mole inverse. Then Mb is molar mass. So molar mass of the solute is 256. So molar mass of solute is 256 gram per mole. Then weight of solvent. So Wa is what? Weight of solvent. So weight of solvent is what? Benzene. Here the solvent is benzene, 75 gram of benzene. So benzene is a solvent. So that is why Wa is what? Solvent. Weight of solvent is 75 gram. Now we want to find out the Wb. So substitute these value into this formula. After writing this, you will get half mark. Apply the value, you will get one more half mark. That's mean suppose if the question already in that question is 2 mark question. In case writing of these two values formula and apply the values mean you will get half of the marks. See here the delta Tf is what? 0.48, then Kf is 5.12, then Wb we want to find out, then 1000 divided by Mb is what? 256, then Wa weight of solvent is 75. So now you have to write the rearrange the formula, that is Wb. So Wb into this, that's mean on rearranging this you will get 0.48 into 256 then into 75 divided by 5.12 into 1000. So simplify this. See, take log value this 0.48 and add again one more log value, then log value for 75. All these three you have to add, then take log value separately for these two values and subtract these two value and you will get the final answer. That final answer you have to take the anti-log. So that is the method. You can use it the logarithms method or the simple calculation. Just do it this. Now see, I hope you may get that is 1.8. So here the WB, weight of the solute. So weight means you have to indicate the unit is what? Gram. So 1.8 gram. WB is 1.8 gram. This is the answer. So mass of the compound is 1.8 gram. See, the next sum is based on the boiling point. Already we seen the freezing point based sum. Now boiling point based sum. When 1.5 gram of non-volatile solute was dissolved in 90 gram of benzene, the boiling point of the benzene rised from 353.23 Kelvin to 353.93 Kelvin. Calculate the molar mass of the solute. So we want to calculate molar mass of the solute. That means MB we want to calculate. Now write the formula first. So delta TB is equal to KB into M. Know that M, the whole term is KB into, that is WB into 1000 divided by MB into WA. So this is the formula. Now check it, what are the values are given here. The KB value for benzene is given. So that write KB value. KB is equal to 2.52 Kelvin kilogram per mole. Then next, the WB, weight of solute. So WB means weight of solute. Here when 1.5 gram of non-volatile solute, so that here WB becomes 1.5 gram. Then MB we want to find out. WA, the WA is solvent. So solute, one non-volatile solute was dissolved in 90 gram of benzene. So it will become, benzene is a solvent. So that WA is 90 gram. So WA is 90 gram. Then we want to find out the delta TB. So delta TB is equal to, already we know that delta TB is equal, that is delta TB not minus delta TB. So that means 353.93 minus 353.23. So this is the value. So that's so 0.93, 0.23, it will become 0.70 Kelvin. So this is the delta TB value. So delta TB is 0.70 Kelvin. Now apply this value in this formula, will get the final answer. So delta TB is what? Here the write again, delta TB KB WB 1000 divided by MB into WA. So write this value here, 0.70. So rearranging the formula, so you want to find that MB value, so that just write here the delta TB and MB, just exchange here, rearrange, delta TB is here. Now KB, the KB value is what? 2.52 into WB is 1.5 to 1000 divided by delta TB. Delta TB is what? 0.70 into WA is 90. So simplify this value, taking of log or using of the simple calculation, just do it. See, the final value is, you may get, that is 60 gram per mole. So because the MB means molar mass of the substance, the unit is gram per mole, that is why 60 gram per mole. So this is the final answer. See, writing of the unit is very important because the unit carries half mark. So writing of unit means very important. Wrong, either you have to without unit, or writing of the wrong unit means definitely you are losing that half mark. So the unit carries a mark. See, look at this numerical. 18 gram of glucose, that is C6H12O6, the molecular mass is given 180 gram per mole. So 18 gram of glucose is dissolved in 1 kilogram of water in a saucepan. At what temperature will this solution boil? So this is the question. The boiling point of the pure water is given here, that is 373.15 Kelvin. Kb for water also given here, that is 0.52 Kelvin kilogram per mole. Now here, what temperature will this solution is boiled? So delta Tb, first we want to find out the delta Tb. Kb is given, so that Kb values I am written here. Then Wb, weight of solute. Weight of solute is what? Glucose, 18 gram. Then weight of solvent is water. So weight of solvent, that is 1 kilogram. So conversion of gram, 1000 gram. Then Mb, molecular mass of the solute is 180 gram per mole inverse. Now the boiling point of the water is delta Tb is equal to Kb into M. That M is the whole value, that is Kb into Wb 1000 divided by Mb into Wa. Now you know that the delta Tb you want to find out. So delta Tb is equal to Kb is what? 0.52 and that Wb is 18 into 1000 divided by Mb is 180 into Wa is what? Wa is 1000 gram. So here you have to cancel this thing, then you will get this delta Tb boiling point of water as it will become 0.052 Kelvin. So this is the boiling point of water. Then boiling point of the solution. Boiling point of the solution. So solution means here you have to calculate what temperature will this solution boil. So boiling point of the solution is Tb0 plus delta Tb value. So here the boiling point of pure water is, that is boiling point of pure water is 373.15 Kelvin. So 373.15 Kelvin. Then delta Tb is 0.052 Kelvin. So adding of these two value, you will get 373.202 Kelvin. So boiling point of the solution is 373.202 Kelvin. So this is the answer. So already we seen that freezing point of that Kf value, that is Tb delta Tf. Then after that we seen that delta Tb and the Kb. Now we'll see osmotic pressure based problem. See the next sum. Before going that osmotic pressure, we will discuss some relative lowering the vapor pressure based sum. See the vapor pressure of water at 20 degrees Celsius is 17.5 millimeter of mercury. Calculate the vapor pressure of water at 20 degrees Celsius when 15 gram of glucose is dissolved in 150 gram of water. So we have to calculate the vapor pressure of water at 20 degrees Celsius. First, you know that the vapor pressure of water at 20 degrees, see the pure solvent, that is vapor pressure of the pure solvent is P0A. So P0A is what? Here 17.5 millimeter of mercury. Then PA. So that vapor pressure of the solution. PA is vapor pressure of the solution that we want to find out. So this we want to find out because the vapor pressure of the solution here water at 20 degrees Celsius when 15 gram of glucose. This will be a PA is what? Vapor pressure of the solution. P0 is vapor pressure of a pure solvent. Okay, that is then W B weight of the solute. Here the weight of solute, vapor pressure, calculate the vapor pressure of water at 20 when 15 gram of glucose. Here solute is what? 15 gram. Glucose is a solute. Then weight of solvent. Weight of solvent is what? Weight of solvent is water. Here 150 gram. Weight of solvent is 150 gram. That is also given. Then MB, molecular mass of the solute. The molecular mass of the solute is 180 gram per mole inverse. Now you know that the formula, that is P0A minus PA divided by P0A is equal to, that is mole fraction of B. See these value, check it again, that value P0A value is given here, then the PA is given here, then WB, MB, then WA, then the missing value is MA, that is molecular mass of the solvent. The molecular mass of the solvent is what? Water, solvent water. So that 18 gram per mole inverse. Now you know that formula P0A minus PA divided by P0A is equal to mole fraction of B, that is mole fraction of the solute B. So this will become, that is simply we denoted N2 divided by N1 plus N2. So N2 is divided by N1 plus N2. Then usually N2 is what? That is WB divided by MB. Similarly WA divided by MA plus WB divided by MB. So this is the well-known formula. Here when the WB divided by MB is very less than WA, that is N2, simply N2 is very less than N1, means that is you have to neglect this term in the denominator. So simply you can write it, the formula is P0A minus PA divided by the P0A is equal, that is WB divided by MB, then whole divided by, that is WA divided by MA. So this is the formula, rearranged formula. Now substitute these value in this formula. So P0A is what here? 17.5 minus PA divided by 17.5. Then WB is what here? WB is 15 divided by MB. MB is 180 whole divided by WA. WA is what? 150 divided by 18. So just simplify this. After simplifying you will get that PA value. Just do this calculation. See, finally the PA value is this 173.5, that is millimeter of mercury. So vapor pressure of a solution is 173.5, that is 173 not 173, 1732.5 millimeter of mercury, or you can write it 17.325, 17.325 also, right? That is 17.325 millimeter of mercury. The next sum. A solution is prepared by dissolving 5 gram of non-volatile solute in 95 gram of water. It has a vapor pressure of 23.375 millimeter of mercury at 25 degrees Celsius. Calculate the molar mass of the solute. So vapor pressure of a pure water at 25 degrees Celsius is 23.75 millimeter of mercury, that is given here. So again write the formula P naught A minus PA divided by P naught A. So is equal to mole fraction of B, that is mole fraction of the solute B. That means already you know that is W be N2 divided by N1 plus N2. So N2 is what here? WB divided by MB, that whole divided by WA divided by MA plus WB divided by MB. Here that N2 is very less than N1. So that neglect the term in this denominator, that is N2 is neglected. So finally you will get P naught A minus PA divided by the P naught A is equal WB divided by MB, that whole divided by WA divided by MA. Now find here the pure water, that is vapor pressure of the pure solvent. That is pure solvent is what? Water at 25 degrees Celsius is to 23.75. So that right here P naught A is equal to 23.75 millimeter of mercury. Then PA vapor pressure of a solution. So vapor pressure of a solution is 23.375. 23.375, that is millimeter of mercury. Then weight of solute. So weight of solute is, the solution is prepared by dissolving 5 gram. So weight of solute is 5 gram. Then the MB we want to find out. MB we don't know, we want to find out that value. Then WA, weight of the solvent. So weight of the solvent that is prepared by dissolving a 5 gram of non-volatile solute in 95 gram of water. So that 95, weight of the solvent is 95. Then molecular mass of the solvent is, water is what? Water molecular mass is 18. It is 18 gram per mole. So this is the value. Now substitute these value in this formula, will get this 23.75 minus 23.375 divided by 23.75 is equal, WB is what here? 5. MB we want to find out, MB divided by WA is 95, then divided by 18. So simplify this term and finding the MB value. So you have to find the MB value. Rearrange this formula and find this value. Now the value is here 23.75 minus 23.375, you will get 0.375, then divided by 23.75, 5 divided by MB into 18 divided by 95. So after simplifying, that is MB, after simplifying this, you will get that is MB is equal to 60 gram per mole. So this is the answer, 60 gram per mole, because the calculate the molar mass of the solute. Here the molar mass of the solute is 60 gram per mole. Now we will see the osmotic pressure based numerical. See, the next sum is osmotic pressure based sum. At 300 Kelvin, 36 gram of glucose, that is the glucose present per liter in its solution has an osmotic pressure of 4.98 bar. If the osmotic pressure of another glucose solution is 1.52 bar at the same temperature. So calculate the concentration of the other solution. So that's mean here the two different concentrations are given. That's mean the C1 and the C2. C1 and the C2 value. See, C1 and the C2. So calculate the concentration of the other solution. So we want to calculate the C2 value. Then that's mean here the two different osmotic pressure, that's mean two different pi value, pi 1 and that pi 2 values are given. So the formula will be pi 1 divided by pi 2 is equal to C1 divided by C2. So this is the formula. So here the pi 1 value, 36 gram of glucose C6H12O2 is present in the per liter. So concentration means number of moles of solute divided by the volume. N concentration usually N by V, that is here C1 means you have to use that is N2 divided by V. C2 we want to calculate. So the number of solute, already volume is present per liter in solution, so that you have to use that N2 is WB divided by that MB. You know that. So remind this term here. Then the pi 1. Pi 1 is the osmotic pressure. So 4.98 bar. Then the pi 2, another solution. So this is the another solution of the osmotic pressure of the another solution. So that pi 2 is 1.52 bar. Okay. Then the C1. C1 means what here? N2 by V, so that N2 WB by V, MB. So WB is what here? WB is weight of that solute. So weight of the solute is 36 and molecular mass of the solute is C6H12O6. That means 180. C6H12O6 that is molecular mass of the solute is 180 gram per mole, and the weight of solute is, that is WB, this is MB and this is WB, 36 gram. Now substitute these value in this formula. So pi 1 is 4.98 divided by pi 2 is 1.52 is equal C1. So C1 is what here? It is the N2 is called C1. So WB divided by MB. WB is what here? 36 and MB is what? 180 divided by the C2. See, I repeat here. The C1 means what? That is N2 by V. Already the question, read the question properly. Present per liter in the solution. That is why N2 by V converts to that N2. That's equal to C1. So N2 is usually what? Weight of solute divided by molecular mass of the solute. That is indicates C1. So that I am substituting here. This is imagine this is WB and this is MB. This is WB. So WB is what? Weight of solute. So weight of solute is 36 gram divided by the molecular weight of the solute is 180 gram per mole. So after simplifying this, see, you will get that C2 value. The C2 is, so C2 is 1.52 divided by that 4.98 into that 36, that is 36 divided by 180. Simplify this, you will get the answer. So the final answer is 0.061 mole liter inverse or mole per liter. So this is the concentration of the other solution value. Okay, student. See, already we seen that Kf freezing point, then boiling point. After that we seen vapor pressure, lowering the vapor pressure. Now the osmotic pressure. So this is the numerical based questions, that is colligative properties. Then we see next is the theoretical types of the questions. Already we seen that numerical based question. This is the theoretical types of question, like the definition. Some definitions are given. That question is colligative properties. Define the colligative properties like this. Define the molarity and the molality and the molarity. Then define ideal solution. Then Henry's law, Raoult's law. So these type of the questions also will come. See, first I will tell you the answer for the colligative properties. What is the colligative properties? Here the answer is those properties which depend upon the number of particles of solute present in solution and not and nature of the solute. So this is the colligative property. I repeat this. The properties which depend upon the number of particles of solute present in solution and not on nature of the solute. So this is called colligative properties. Next, the term molality. The term and the molality. Molality usually the number of moles of solute dissolved per kilogram of the solvent. Number of moles of solute dissolved per kilogram of the solvent. Then the molarity. This is small m, this is capital M, molarity. The molarity is the number of moles of solute dissolved in per liter of the solution. This is the kilogram and this is the liter. In terms of used molarity, liter, molality using kilogram. So this is the difference. This is small m and this is the capital M. Then the third is the ideal solution. What is that ideal solution? See that solutions obeys Raoult's law. So the simple term is, the simple answer key is the solution obeys Raoult's law. Suppose non-ideal solution mean the solution does not obey Raoult's law. This is the simple term, or some brief explanation mean the Raoult's law over a wide range of the concentration at the specified temperature. That means here the no heat is evolved or absorbed. So no volume change, no heat change, that means no entropy change, no enthalpy change at any proportion. So that is called ideal solution. Simply you can write it, it obeys Raoult's law. That is called ideal solution. Non-ideal solution means it does not obey Raoult's law, because they have a different volume. Sometimes that is they attain equilibrium, the delta H mixing is greater than 0 is possible, then less than 0 also possible. That's why the different deviation, positive deviation and the negative deviations are there. So the ideal solution means simply write it obeys Raoult's law. Non-ideal solution means does not obey Raoult's law. Then the Henry's law, statements of the Henry's and the Raoult's law. So here what is meant by Henry's law? Here the partial pressure, involving the partial pressure of the gaseous molecule. Henry's law mainly discusses about the gaseous molecule. So the partial pressure of a gas dissolved in a liquid is directly proportional to the mole fraction of a gas. You must finish with mole fraction of a gas, because mole fraction of the solution also there. That is why in Henry's law you must finish with mole fraction of a gas. I repeat this, partial pressure of a gas dissolved in a liquid is directly proportional to the mole fraction of the gas. Here you know that the formula is P is equal to KH into X. That is KH is the Henry's law constant and the X is the mole fraction. So P is the partial pressure of the gas. See, when the temperature, suppose the KH value, the temperature is increased, the KH also increases, because the solubility of a gas is liquid is decreases. Solubility of a gas in a liquid is decreases. You know that example, the carbonic acid, soda water. Then the Raoult's law. The Raoult's law, statements of the Raoult's law. Here the partial vapor pressure of each component is directly proportional to their mole fraction of the both solute and solvent or volatile. So this is the Raoult's law statement. I repeat this, the partial pressure, vapor pressure of each component is directly proportional to their mole fraction if both solute and solvent are volatile. So this is called Raoult's law. So this is some definition terms of the solution lesson. See here the question is, on mixing liquid X and Y, that is liquid X and the liquid Y, the volume of the resulting solution increases. So mixing of X plus Y is increases, then what type of the deviation from Raoult's law is shown by the resulting solution? You know that mixing of that solution, the two liquid is increases mean they show the positive deviation. For example, X plus Y, the liquid of X plus Y is mixing means the volume of the resulting solution is what happened. For example, this is X solution and this is Y solution. So mixing of these two solution, what happens? So the XY solution is increases. On mixing of a liquid X and the liquid Y, the volume of the resulting solution is increases. So the what type of the deviation shows? Usually increasing means the curve is increasing means that shows the positive deviation. You know that this shows the positive deviation. So the answer is, the first answer is positive deviation. Then there is one more question. What type of deviation, what change in the temperature would you observe after mixing the liquid X and Y? Definitely the temperature will decreases. So temperature will decrease. The first answer, on mixing liquid X and liquid Y, the volume of the resulting solution increases. So what type of the deviation Raoult's law is shown by the resulting solution? So here the first answer is positive deviation shown from that Raoult's law. Second is, what change in temperature would you observe after mixing the liquid X and Y? So temperature is decreases. So you have to carefully note that question, because that is simply writing one question, but this question having the split up is two different marks. That means this is 2 mark. Okay. So here one question carries shows the positive deviation 1 mark, and the temperature decreases carries 1 mark. So you have to carefully read the question and answer the question properly. Then the second question, how can the direction of the osmosis be reversed? You know that and the one more question also there, write one use of the reverse osmosis. So two different questions are there. So here what is that answer means, the how can you direction of osmosis be reversed? Already you know that when we apply an external pressure on the solution side greater than the osmotic pressure, so osmosis can be reversed. I repeat this, when we apply an external pressure on the solution side greater than the osmotic pressure, osmosis can be reversed. So this is the answer point. Then write one use of the reverse osmosis. Usually that is desalination of the sea water. Using that is, we are using in mineral waters, like we are having the two different type of water, that is, one is reverse purified water, another one is the natural drinking water. The natural drinking water is nothing but it's come from the mountain like this. But purified drinking water is, this is called the reverse osmosis process. That is the reverse osmosis. In mountain range, we have the natural mineral water. But the reverse osmosis water, they contains, there is not much more mineral compared to that natural drinking water. Okay. So here use means just write it, the desalination of the seawater. Look at the question. First question, what happens when we place the blood cell in water and give reason? You know that the cell will swell. The cell will swell and even may burst due to inflow of solvent because of osmosis. So you have to write what happens when we place the blood cells, mean you have to write swell, the first question answer. This is the key point, and the give reason because of osmosis. So the second reason you have to write like this. So there are two different type questions, means what happens when we place the blood cell in water, that one question, give reason, that carries also mark. Suppose if the question carries 1 mark, mean this answer is half mark and this answer is half mark. Therefore what happens when we place the blood cell in water, mean it happens swell. Then give reason because of due to the osmosis. So this is the answer. Then the second question, what does mean by that negative deviation? What does mean by the negative deviation from Raoult's law? Then give example. Then the third question, what is the sign of the delta H mixing for the negative deviation? So there are 3 types of answer you have to give. That means what does mean by the negative deviation? See here, you know that the negative deviation, the forces of attraction. The forces of attraction, that is AB forces, AA forces and BB forces. Here AB forces, that AB forces is more than AA forces, more than BB forces. So that is why the negative deviation, it shows the negative deviation. AB forces, the forces of attraction, AB forces is more than AA forces. AA forces is more than the BB forces. That is BB type, AB type and AA type. So that is why the reason. What is mean by the negative deviation from the Raoult's law. So that you have to write the forces of attraction, that is AB are more than AA and BB. Example, chloromethane and the acetone. The second is chloromethane and acetone. Okay, sorry, chloroform and the acetone. Okay, chloroform and acetone. This is the example. Then the third is, what is the sign of the delta H mixing negative deviation? So negative deviation indicates delta H mixing is equal to negative sign. Okay, this is a negative sign. Suppose here delta H mix for positive deviation means you have to write the positive sign. Then third question, what is azeotrope? What is azeotrope? Then what type of azeotrope is formed the negative deviation? What type of azeotrope is formed by the negative deviation from Raoult's law, and give example. Here also you have to answer 3 different types. That is, what is azeotrope? Azeotropes means what? You know that the azeotropes are the constant boiling mixtures which distilled out unchanged in their composition. So this is called azeotrope. I will repeat that. Azeotropes are the constant boiling mixtures which distilled out unchanged in their composition. This is called azeotrope. Then what type of azeotrope is formed by the negative deviation from Raoult's law? Here the maximum boiling azeotropes are formed because the solution showing the negative deviation. That is why the maximum boiling azeotrope. Then example, HCl and the water. Example is HCl and water. So this is the example. Okay. So this type of question, so you have to read carefully that question, then only after that you have to answer. Because sometimes in urgent, just what happens when we place it in the blood cell in water. Suppose if you write only the swell means you may lose the recent mark. Okay, you may get only half mark. You may lose half mark. That is why you have to read properly all the question. That is why they are given 15 minutes for reading time. Hi students, see today we seen the solutions chapter previous year question paper solved. I hope you see many questions are discussed that the colligative based numericals, that is relative lowering the vapor pressure, elevation of boiling point, depression of freezing point, and the osmotic pressure based numericals. After that we were seeing the theoretical concept based question, reasoning type question also we were seen. Just prepare well this examination.